Hi everyone, this is a quick video on how to graph polar equations using your graphing calculator and a table. I'm going to show you some quick ways to get the information you need so that you can sketch a graph of two different types of polar equations. So let's get started. We're going to start with this first one, r equals 4 cosine theta. The first thing you want to do is put your calculator into the proper mode. If you press the mode key, and if you go down to where it says function, and then it says PAR, that's for parametric, and then POL for polar. So you want to arrow over to polar and press enter, and that way your calculator is now in polar mode. Now when you go to y equals, you'll see instead of y1, y2, y3, etc., you see r1, r2, r3, etc. So I'm going to go ahead and put this equation in. So I've got 4 cosine, and I'm going to press theta there. Okay. One thing you want to make sure when you're doing this is that your calculator is in radians. So you're also going to, in the mode menu, you want to go down to radians and enter on there so that you are in radian mode. Now, in order to get these values to come up, if you notice my table is in increments of pi over 6. 1 pi over 6. This is 2 pi over 6, which reduces to pi over 3. 3 pi over 6, which reduces to pi over 2. 4 pi over 6, which is 2 pi over 3, 5 pi over 6, and then 6 pi over 6, which reduces to pi. What I'm going to do is I'm going to go to the table set. So I'm going to go second window, and I'm going to start my table at 0, and then the increments that I want to do is pi over 6. So if I hit that second key and get pi and then divided by 6, and that's going to make each of my entries go up by pi over 6. So if I were to go ahead and in y equals, I have my function in there already. If I were to go and hit second graph to pull up my table, I would see some values in here. And I have to do one other thing on my table. I want it to be on auto, not on ask. Okay, and that will automatically generate the table for me. So let me go back to there. Okay, so you see all these values in here. So I've got when theta is 0, r is 4, so I'll plot the point 4, comma 0. Okay, my next one is pi over 6, and that is 0.5236. That gives me an r value of 3.46. So we'll say 3.5 because we're just going to estimate that on our graph, so that would be 3.5 comma pi over 6. Right, so that's going to be the point I graph. Then the next one is 1.0472, so that's an r value of 2. Then I have an r value of 0. Then I have an r value of negative 2. Then I have an r value of negative 3.5. And then an r value of negative 4. So you can see how this is kind of going cyclically, and it's you'll see as we graph it how we're going to go about doing that. So when theta is 0, I'm at r is 4, so I'm going to count out 4 from the pole. 1, 2, 3, 4. So there's my first point. At pi over 6, I'm at 3.5. At pi over 3, I'm at 2. Oops, I'm at 2. So at pi over 3, I'm at 2. 1, 2 is right here. At pi over 2, I'm at 0, so I'm right here. At 2 pi over 3, I'm at negative 2, so I have to flip over my pole. So here's 2 pi over 3, comma 2, so negative 2 flips me over the pole. So I'm down here. 5 pi over 6 flips me over the pole, so that would be on the 11 pi over 6 line. So I'm going to go 1, 2, 3.5 out there. And then at pi, I'm at -4, so that flips me over the pole and puts me back here. So these are the points I've plotted now. It doesn't give you the exact shape. You're not just going to connect the points. If we were to go ahead and graph this on our calculator, if we were going to do zoom 5 to give me a square graph, you'll see that it's actually graphing a circle. And my circle kind of got cut off there. But you can see that it's actually the graph of a circle. So we can go ahead and sketch that circle. We all know that my circle skills are not the best. Oops. But you get the general idea there. We're graphing a circle. Okay, we'll do one more. This next one is the equation r equals 1 minus cosine theta. So I'm going to go back to my calculator. Now that my calculator has all the right settings, all I have to do is go in and change the equation. So I'm going to change this to 1 minus cosine theta. And we can take a look at the graph to kind of get an idea of what it will look like. And you'll see kind of this is what our graph should look like. It kind of has a little dent in there at the origin. But let's go ahead and look at the table. And we'll go ahead and graph it. So if we do second graph to pull up the table. Let's see, when theta is 0, r is 0. At pi over 6, we've got, looks like 0.1. At pi over 3, we're at 0.5. Pi over 2, we're at 1. Then we're at 1.5. Then we're at 1.9. And then we're at 2. So if you want to fill in this last column, you can. But we have our theta and our r here, so we can just get it from that part of the graph, right? And we can just plot those points. Just a quick backtrack here. Remember that we put our, when we set up our table, we went up in increments of pi over 6. So that's how I know that these decimals match up with my values here. And you could always test it out. Like if you go down to the fourth one, 1.57, right? If you take pi, 3.14, and divide that by 2, that'll give you 1.57. Right? And so pi over 2, right, that's that 1.5708 number in the calculator. So these are just decimal representations of our radian measure. In my table here, I just have it in something that's more recognizable to us, but your calculator is going to put that in decimal form for you. So let's go ahead and plot these points. So I've got 0, 0. And then at pi over 6, I'm at 0.1, so I'm just a smidge kind of away here. At pi over 3, I'm at 0.5, right there. And at pi over 2, I'm here at 1. At 2 pi over 3, I'm at 1.5, so I'm out here. At 5 pi over 6, I'm at 1.9, so I'm almost out here at 2. Right there. And at pi, I'm out here at 2. So you get an idea, right? My graph is doing this. And then as you can see from the graph, if I go back to the graph here, you can see that this is symmetrical about that x-axis. So I can pretty much plot those same points on the other side here because I know that I'm going to be symmetrical. So I know at 7 pi over 6, I'm going to be just shy of 2. 4 pi over 3, I'm down here at 0.5. This is here at 1. I'm at 0.5 and 1. So my graph looks like kind of like this. So we all know that I'm not the best grapher here, but that's the general idea. And that's basically what that graph looks like. Mine's a little kind of dented, but you get the general shape of it. So that's how you can go about sketching these graphs using your calculator. You don't have to do this out by hand. You can do it all right in the calculator. Just make sure you set it up properly to start. And like I said, if you need to go back to the beginning of the video and look at those different settings, you can do that. Quick review. Mode, you want to make sure you're in polar. Polar mode, that's the fourth option down. And you want to make sure you're in radians. And then when you set up your table, to make sure your table goes up in increments of pi, I did pi over 6. You could do pi over 12. You could do whatever increments you want. I just did pi over 6 increments. If you hit second window, and if you start your table at 0, and then that little triangle means the change in the table, how much you want to go up by. And again, you can just put in pi divided by 6, and it'll change that to a decimal for you. And then your table, your calculator is all set up ready for you to just plot the points to graph your polar equation. Okay, that's the setup for what we'll be doing tomorrow. I just wanted to show you how to do it in the calculator. Tomorrow we're going to do some other ways to recognize graphs, and we'll talk about some shortcuts to get to what we need. But I wanted to show you how to do that in the calculator. All right, thanks everyone. We'll see you next time.